Solutions. Remember, if you're not part of the solution, then you're part of the precipitate. Haha. So what is a solution anyway? That is a homogeneous mixture in which the physical properties are dependent upon the concentration of the solute and the strength of all of the interactions among the particles of that solute. And of course the solvent. So it's the interaction amongst the molecules inside of the liquid that will give solutions their properties and their overall classification. So a little vocabulary here. A solute is the dissolved substance in the solution. So if I'm going to dissolve salt in water, then salt is my solute. If I'm going to dissolve sugar inside of soda drinks, then sugar is my solute. Have you ever opened up a bottle of soda and you see little bubbles come out? That's a dissolved gas, carbon dioxide, inside of the soda drink. Now the solvent is the dissolving medium in the solution. So if I'm making salt water, then water is my solvent. And if I'm talking about soda, sugar dissolved in soda, carbon dioxide dissolved in soda, then again, it's water that is the solvent. That's the substance that everything's dissolving in. When we want to create a solid liquid solution, the first thing we got to do is we got to break up the solute into like its individual components. So that's expanding the actual solute. So you have to overcome all of the intermolecular forces in the solvent to make room for the actual solute. So again, you're going to also have to expand the solvent. This allowing the solute and the solvent to interact to form a solution. So in other words, you have to expand the distance in between the solute particles and the solvent particles in order to create an interaction between the solute and the solvent, essentially interrupting the intramolecular forces that are happening in between them individually. So here we have an illustration about how that works. Here I have my solvent, and it has particles that are becoming separate from that actual solid. So energy is absorbed, and the solvent particles are moving farther apart, allowing those particles to enter the liquid, i.e. absorbed into the liquid. And then the solvent particles, being that now they're attracted to the solute particles, will interact with them, and we will see the solid or the gas dissolve. So how fast this happens and how it happens really all depends on the strengths of those intramolecular forces that are between the solute particles, also between the solvent particles as well, because it's not always water. And so the strength of the solute-solvent interaction becomes important. There's a general rule. We say like dissolves like. And what that means is that the more things are alike in their properties, the more likely they are to dissolve each other. Particles of a solute are going to dissolve if it is more attracted to the solvent than it is itself. So it has to want to be in the solvent more so than it wants to hang on to itself. There's another factor here when we're talking about items dissolving into something. That's right, polarity. So why is water so great? And that's especially when it comes to forming solutions. And that's really because water's polar. And what does that mean? Kind of like a polar bear? No, as we talked about before, polar means the molecule has poles. So here we have the water molecule. There's our hydrogens. And there's our oxygen. The hydrogens are feeling partially positive while the oxygen is feeling negative. Hence, this molecule has poles. It's like an uneven distribution of charges here. Makes the molecule feel one way on one side versus the other. The electrons like to spend more time in one area versus the other. This explains why water doesn't dissolve oil, or oil doesn't dissolve in water, I guess depending on how you're looking at it. the interactions between the water molecules themselves, they're stronger than the interactions between the water and the oil molecules. So oil is nonpolar, and it doesn't interact with other polar molecules. So because oil is nonpolar, it's only going to interact with nonpolar things. Remember, like dissolves like. So in order for something to get dissolved into water, water is polar, it likes to dissolve other polar molecules.